So as we said, this is a quantification experiment, and our goal is to figure out the concentration of nickel 2 plus in each of these 24 different samples. And to do that, we're going to use a method where we develop what's called a standard curve. And one of the things you'll find out about standard curves is that they're almost always straight lines. So not really curves, but we're going to make a standard curve and then use that to determine the concentration of nickel for each of these. And the way we're going to do this is we're going to use the property of nickel that it absorbs some visible light. And so I have two samples of solutions of nickel here that I made up. And you can tell that they are different concentrations because one's just darker than the other. And so this one clearly is darker green than this one is. And so from that, we can infer, and correctly so, that the concentration of nickel in the left-hand sample is greater than the concentration in the right-hand sample. And that's really what we're going to be doing. We're going to be looking at how dark a solution is and relating that to the concentration of the samples that we're going to be trying to analyze. A standard curve is a pretty magical thing. It's an example of an activity where you spend a little bit of time up front to figure something out, and then you can use what you found out to do a lot of other things really well and really quickly. It's kind of like making a map. When you make a map, what you do is you spend a lot of time up front figuring out where things are and figuring out where the roads are between them. But once you have your map, you can take thousands of different routes from any place to any other place that's found on that map. And so the time up front to make the map allows you to do lots and lots of other things down the road, as it were. And the standard curve is the same kind of thing. Once you make the standard curve, you can analyze thousands of samples using that curve to figure out the concentrations of those samples. So the way it works is what you do is you measure your standard solutions for which you know the concentration. You measure their absorbance. And you make a plot of absorbance on the y-axis and concentration on the x-axis. And then here are the points we get from that. And then what you do is you draw a straight line that goes through those points. And we know it's a straight line because of Beer's law, where we know absorbance is proportional to concentration. So you draw the line through those. Okay? And then what happens is, if you're going to have now measure an unknown sample, what you measure its absorbance. Let's say its absorbance is around, like 0.32. And then what you do is you go across to the line, and then down, and then that tells you what the concentration of that sample is. And of course, we're not going to use a board and rulers. We're going to actually do this mathematically. So we're going to make the plot in Excel, and we're going to find out the equation for this line, which will be in the form of y equals mx plus b, where y is going to be the absorbance, and x is going to be the concentration of nickel 2 plus, and m is going to be the slope of that line. And so using the straight line equation that we find by using our standard values and putting them into Excel is going to allow us to have a mathematical equation that relates absorbance of our unknowns to their concentration.